So here's the exam. Okay, let's just find. Was this June exam? Ach, this physics. No, that's last year's November exam. Let me find. Okay, so here's one of the multiple choice questions. The pH of KOH, is KOH a strong or a weak? Well, I suppose they tell us. The pH of a KOH solution. In other words, we have, what is that? An acid or a base? That's a base because it would donate OH ions. That pH is 11.2. Which one of the following statements is true? Is the hydroxide and the hydronium ions concentration equal? Is there more K ions, potassium ions, than OH ions? Is there less hydronium ions than hydroxide ions, or is there less hydroxide than hydronium ions? Which one? Candile? C. Why do you say C?
Because hydronium ions are distributed by acids. So obviously, since it's not an acid, that means their concentration is lower.
Yeah. Okay, that's good. Okay, so again, 11.25. Okay, if it was 7, it would have been equal. So again, whenever you see hydronium, for me, I just replace it in my mind with hydrogen. I don't know why they use this. I don't like it. But anyway, I use hydrogen. So if these two were equal, then it would have been 7. Okay, because when I add them together, it must give me 7. Okay, this one, you could also look at it like this. Since you know that the pH is that, so if pH, no, I don't want to go into that right now. Okay, so if the pH is more than 7, it means there's more hydroxide than hydrogen. If the pH is less than 7, there's more hydrogen than hydroxide. So this one is more than 7, so there's more hydroxide than hydrogen. So C. Do you have questions on that? Is that difficult for any of you to see? Bakani? Do you understand that?
Yes.
Are you sure? You guys? No, it's really simple, so you should have fairly confidence to understand what I just said. So I can try and say it better. Okay. So you missed what I just said, unfortunately. But when in water, if I take the concentration of hydroxide and hydrogen. Okay, so in there they now use H3O+, so just ignore that. Try and think in terms of this. You will get 10 to the power of -14. Okay, now these two in water, you will always get this, by the way, sorry, it's not just in water, this will always be true. When you take hydroxide times hydrogen, you will get 10 to the power of -14. If you have a water solution with no matter what you put inside. But when you add, and in water these two are the same. So in water you get OH is equal to 10 to the power of -7 and H is equal to 10 to the power of -7. So that when you multiply them, you add the exponents and you get that. Okay, so this is the case in water. But now if I add an acid, I'm increasing this concentration. Okay? Now what is going to happen with this number, with that 7, if I increase this concentration? Is it going to become more or less? It's going to become less because it's -7. If I increase -7, it will become -6, -5, -4. Do you understand? So in other words, if I add an acid, this one will decrease. And this pH, this exponent, if you take away the negative from that exponent, that is your pH. You understand? So when I add an acid, now when I add a base, this exponent, so if I've added an acid, I will find that this is larger than that. Because if I increase this one, but then, I've increased this one, so this one becomes negative something, but then this one must become positive, also negative, but this one must become a bigger number because it must still add up to 14. So for example, if this one is -4, then this one must be -10. Okay, and then if you compare the pHs must, I don't want to go into there. Okay, so in our case, we saw that the pH is 11,2. That means that h to the power of +1, h to the power of positive is equal to 10 to the power of -11,2. And so O to the H, this one is now 10 to the power of, they must still add up to 14. So this one must be to the power of -2,8. So which one is bigger? Which of these two numbers is the biggest number? OH is bigger. Why? Because his negative exponent is smaller. Does that make sense? A -2 is bigger than a -11. You understand? So that is why here we have OH is larger than H plus. Make sense?
Yes.
Okay. But when you do a few of them, you'll understand. The moment you add a strong, and this is a strong base, to a solution, you are increasing the hydroxide ions. So you have to have, if you add a basic, if you have a basic solution, you always have that this is true. Okay. Okay, a learner determined the pH of a number of solutions at 25 degrees Celsius. She obtained the following results: pool acid, lemon juice, and drain cleaner. Okay, she measured the pH of these things. Which solution contains the highest concentration of hydrogen ions? So you should be able to just see it, but you want hydrogen ions. Okay, hydrogen ions. Your concentration of hydrogen ions is always equal to 10 to the power of negative pH. So if you have the pH, you can get the concentration of hydrogen ions. So in other words, we had pool acid was 10 to the power of -1. Okay, lemon juice was 10 to the power of -3,2. 3,2. The drain cleaner is 10 to the power of negative, what was that? 13. 13. -13. Which one of these three is the highest concentration? Is the biggest number? 10 to the power of -1. Do you again? I'm not impressed with your maths, I must admit. No one is saying that that is the biggest number. That's indeed the smallest number. Okay. Now, if I wanted to know what is the OH concentration, so if they ask me which one has the biggest hydroxide concentration, I must just go and subtract that from -14. So this one will have -13 for the pool acid. 10 to the power of -10,8, and this one 10, this would be the hydroxide. Okay, but again, most of you should be able to see it as the higher your pH, the lower your H concentration. There's an inverse relationship there because pH is negative log. The moment my relationship has a negative in front, it's inverse. The gradient is downhill. So if the one increases, the other one decreases. Okay? Calculate the concentration of hydroxide ions in lemon juice. I just did it. Okay? For how many marks is that? Huh. Is it really that easy? Okay, let me quickly see. Okay, if it really is that easy. Okay, so they say pH, they give us the pH. pH is 3,2. Now I know pH is negative log of, no, sorry. I don't, yeah, it is true, but I don't want pH. I don't want, pH stands for negative log of H. I don't want hydrogen, I want hydroxide. So I must use, I want POH. POH. Okay? Now if I have pH, all I do to get POH is take 14. So this is 14 minus pH. So if I know pH, I know POH is equal to 14 minus 3,2. And that gives me 10, 8. Now I know that this formula is P is always negative log. Okay? OH is the concentration of OH. Okay? Now, if I want to now solve this, I need to first get the log on its own. So this is log 10 OH is equal to negative 10,8. And now I just use my math, my understanding of logs, to convert the log form into an exponential form. So this is that OH, that, yeah, OH is equal to the base with the exponent. Oh, sorry. That's the answer I had, isn't it? So for 5 marks, I think it would be great if you guys just understand that if you know this formula instead. And OH is 10 to the power of 14 minus the pH. How easy is that? Why would they give you 5 marks for that?
No, maybe they expected the calculation is just...
Yeah, they didn't say it. Yeah. But nevertheless, if you understand, and I suppose that's why it's now easy for us actually to get it quickly there, because we did a lot of, you guys went piano, but a lot of calculations on how to get there. Okay, and how will the pH of pool acid change when, okay, so I'm going to write increase, decrease, or stay the same, if distilled water is added to it. So we have pool acid, now we add water to pool acid. What will it do to the pH?
Distilled water is just water.
Yeah.
Oh, wow. Should increase.
Increase.
I also think it should increase. I think a lot of people might say it should stay the same. That was my original answer when I answered this question. It should stay the same because you're not adding hydrogen. You are adding hydrogen, but you're also adding hydroxide when you add water. You're adding H and OH, so H2O. But the problem is, once you add water, your Ka value is this. You've got your pool acid, the ions here, and your pool acids concentration down here. So once you add distilled water to this, you don't increase the hydrogen ions, okay? Because for every hydrogen ion that you added a hydroxide ion. But what you are doing is you're decreasing the pool acid concentration, because you're increasing the volume. So if the concentration for pool acid is the mole of pool acid divided by volume, when you add water to it, you're increasing volume. So you are definitely changing this, and that affects your pH, definitely. So I agree with you guys are all correct intuitively, that when you add water, you're kind of adding a neutral element you're adding sevens to a 1.
Yeah.
Does that make sense?
It's at 7 and then something like that.
So you guys get it? I will also say it increases it. Okay. What would happen if drain cleaner is added to it?
Increase.
It will also increase, huh?
Yeah.
Quite a bit more. Okay. As a class project, learners were asked to determine the amount of inert, that's unreactive impurities, in a contaminated sample of anhydrous oxalic acid. Again, most people would read that and they'd be totally intimidated by the name. And don't be. Okay. One group of learners prepared a standard solution of sodium hydroxide by diluting 50. Okay, so guys, there's a difference here, and I noticed some people, I didn't know that before. I thought standard solution means 1 mole per cubic decimeter, because that's what standard solution means in the that's the standard solution for electrolytic solutions. But a standard solution just means it's a known solution. So if they say standard solution means it's a known solution, I know what the solution is. And so they prepare a standard solution. In other words, this is going to be a titration. And remember, in a titration, we need a known concentration and an unknown concentration. And the known concentration is called the standard concentration. So standard concentration of sodium hydroxide by diluting, and now they tell us how much they're diluting 50 cubic decimeters of that in a 1 cubic decimeter volumetric flask. Okay? Then they then prepare a solution of contaminated oxalic acid by dissolving 0.75 grams of the oxalic acid in 100 cubic centimeters of water. The acid was then titrated against the sodium hydroxide solution. The titration required 44 cubic centimeters of sodium hydroxide solution to reach the end point. End point would be that, I think that's a question. What is meant by end point? What do you think would, sorry? Yes, the end point is when the reaction is neutralized, when the unknown which one is unknown? The acid. Yeah, when the unknown acid has been neutralized. Because that's the whole aim, is I'm having a bowl here at the bottom with the unknown acid in. I've put in an indicator that changes color. Now, once that color shows me that the pH is 7, I've reached my end point. In other words, it's the point where my acid was, the acidic solution, was neutralized. Make sense? Okay, so as I explained it earlier, what am I going to need? And it helps to draw the picture. Well, it helps me. Is I have, and let's just do a rough sketch. I have my container dripping. Let's do it better than that. Okay. I've got my container here that is dripping in to my container here at the bottom that contains my unknown concentration. Okay, concentration is unknown. All I know about this is the grams. I know how many grams, I know the volume. Okay? Up here, we know the concentration and we know how much of this was used. So we don't care how much was originally there, we only care how much was used. So we know the concentration must be known because it's called standardized solution. So we're going to find, we need to find the concentration. Then from this concentration, we must work out the concentration and volume. We must work out how many moles was used. Because we know concentration, if we multiply that by the known volume, the volume is how much we used, we can know how many moles was used. Now, if I know how many moles was used, the moles of the acid divided by the moles of the base must be equal to the coefficient of the acid divided by the coefficient of the base. And these two values come from your equation, which they gave us, the balanced equation. So we have this, we have that, we've calculated, in the top we had a base, so we have the base. Now we know, now we would know how many, what the moles of acid was that was in here. If we know how many moles of acid was in there, we can work out, and we know the volume, we can work out the concentration, because concentration is that divided by. So now that we know the concentration, okay, it might not be necessary to use that, but we can work out concentration, we can work out, we have moles, we can work out grams. How would we work out? It depends on what they're asking. Once we have mole, the amount of mole in here, we can work out many things. We can work out concentration, we can work out the mass that was in there, because we can take mass is equal to molar mass, moles times molar mass. Okay, so I can work out mass, concentration. So let's just get there at least. If I can get there, I can get anywhere. If I can work out how many moles is in my unknown concentration, from there on I could make a plan to work out anything else. Okay, so let's do that. First of all, what we see we need is we need the concentration of the standard solution. So let's see. They tell me that they prepare a standard solution by diluting. They have this much of that solution. So they have a solution that they are diluting even more. Does that make sense? So in other words, I know that it's taking the, too low down here. Okay, so in the concentration that I'm given, so this is a very long question, it's 10 marks. In the concentration that I was given, that's even diluted even more. Remember, concentration is moles divided by volume. I want to know how many moles is in my original solution. I've got 50 cubic centimeters. Okay, so to find moles, I take my known concentration times my known volume divided by my new volume. Does that make sense?
Why are we dividing?
Sorry?
Why are we dividing?
Because, okay, so think of this. Here I have moles represent how many molecules are in here. Would you agree? Okay. Volume represents the space. Okay. So this is how many molecules do I have per unit of space. But now what I do is I'm increasing my space because I'm saying I'm diluting it even more. Do you understand? So I'm increasing the volume. So I must divide with volume again. So for example, let's say I had my concentration was 2 mole per cubic decimeter. That means for every cubic decimeter, let's just assume 2 mole meant I had 2 balls in it. So in a cubic decimeter space, so here's my space, this is a cubic decimeter. 1 cubic decimeter, I have 2 balls in here. That's my concentration. Now, how many balls, what is my concentration if I double my volume? Did I increase the number of moles? No, but I increased the space. I doubled the space. So
why don't you times the V if you double the space?
I do times the V. But remember, initially concentration was N over V. Now I'm multiplying with a 1 over V. I am multiplying the V's. But do you understand? I don't know how to explain it differently.
I actually
Yeah?
did that equation that you got.
Yeah, so this equation comes down to if you have a diluted solution that you're diluting even more, you take you now have a new, let's call this the new concentration, divided by the new volume must equal the old concentration divided by the old volume. No. Is it?